Hello and welcome to the code walkthrough for the liquidity book vaults. Um, yeah, just wanna show you the basic overview of the vaults, also quick walkthrough how it looks like on the decks, and then I will walk through the code quickly and show you also the repo in detail. As I shared in the documentation, it should be enough to clone the repo and also run the Forge install, and you can also run the basic tests. So, liquidity book vaults. What are the vaults? The vaults, first of all, the vaults are a fork of Trader Joe, aka Let's Fucking Show, and they created it originally, and we forked it from them and create some functionality on top of it. So first of all, the vaults are an abstraction layer based on the liquidity book. Liquidity book is a concentrated liquidity approach like Uniswap v3 or v4 with some key differences, but that's actually not the scope of the audit. So basically, liquidity book is a concentrated liquidity mechanism, and vaults are on top of them to let users get their funds managed by operators. Um, so as you can see in the components, we have the vault factory. The vault factory is responsible for creating the vault and link them to a strategy. The strategy provides the rebalance function, and the rebalance functions deposit liquidity to the pair and yeah and let you also manage the liquidity with one single function called rebalance. Liquidity is deposited, is first withdrawn if there is already liquidity, and then deposited to the liquidity book pair. And from time to time, we also have rewards, and that is transferred back to the vault. The vault, as you can see, the base vault has three types, different types of concrete vaults. We have the simple vault, which is not scope of the audit. So it's done just here for historic reasons. So, and then we have the Oracle vault and the Oracle reward vault. The Oracle vault let you deposit tokens like in the pair to the vault. You can either provide both tokens. For example, if you have a Sonic USDC pair, you are able to deposit Sonic and USDC in a free rate, and you can also deposit single-sided liquidity in a free rate. This is done by when users deposit the tokens, there is a share. The share is evaluated by oracles, by oracle prices, and then an ERC token is minted as exchange for the users that he is holding vault shares, and then the user funds transferred to the strategy, and the strategy deposits those funds in the pair as soon as we do a rebalance. We have another difference because in liquidity book 2.2 you can also create hooks, and based on the hooks, Trader Joe implemented the liquidity book rewarder system, which is like a farming concept based on concentrate liquidity. So if you have active liquidity, you get rewards for providing that. And the original Oracle Vault is not able to handle those rewards, so they just getting lost or just getting stuck in the strategy. So we implemented some functions to manage and handle those rewards, and users are also able to claim those rewards and earn additional rewards, and not only the generated fees by the vault. Yeah, and then another key difference is that the vaults can created by anybody. We have this term market maker vault, so everybody can create a market maker vault, which is basically the Oracle reward vault, and manage user funds. Here we have another, here. I don't want to go into much details or just too deep, because you can read it by yourself, just how the rewards are handled, what is the life cycle of the vaults and the Oracle stuff. You can see by yourself. Let me quickly show you how the vaults are working on the decks. So here you can see the Metropolis decks. We see the maker vaults list. These are all vaults in the testnet, where a couple of vaults are already created. Creating vault is really simple. You just you have the network, you have the pair. It's just this testnet. You just see the pair here. You can freely create the percentage of the OM fee. The OM fee is let's say a payout to the operator that he is managing the vault. And then I see creating a vault is we have a creation fee, which is in the testnet 4S and in the mainnet 400S. So as soon as I create the vault, I have to pay this Sonic, and if I create it, if it will get created, the Oracle reward vault will get created and linked to a new strategy, and the creator of the vault is then the operator of this vault, and operators of this vault have the rights to rebalance. So and let me show you what you can do with the vault if you are the operator. If you are the operator, you have this view. You can simply, you have the liquidity stats, which will show you the total liquidity of the vault. We distinguish between two types of liquidity. One is the active liquidity. This is the liquidity which is active in the pair, and we have liquidity which is idle or is in the reserve. There is some, there can be maybe sometimes there is a need for having a reserve to able to rebalance both tokens, or there are a lot of strategies where you where it's handy to have both types of liquidity, the active and the reserve or idle liquidity, and do a strategy out of it. As a vault operator, I can see both of the liquidity, and I'm able to select both of the liquidities here as percentage, or just as absolute value. I can freely choose how much I want to rebalance, or how much I want to put into active. I freely can adapt the shape, the liquidity shape, and as soon as I hit the rebalance button, this exceeds the exactly. I don't have enough exactly, so here let me just quickly here, then here rebalance. Now it's working. And I can rebalance and manage the funds. So as a user, I can jump into this view I already in this vault, but I can also deposit new funds. So let's say I don't want to provide Ethereum. I just want to provide the basic Sonic token. I just can confirm and quickly jump into, deposit into, and let the magic work for me, or let the operator work for me. Yeah, I can see my balance, how much I already deposited, and I also see how much rewards I can claim. Here we on the testnet, there is no volume, so I don't earn rewards, but I'm able to earn both rewards because I can earn MGEM and Metro, because there are rewarder for that pair and which is emitting those rewards. I can withdraw a specific percentage of my token share, and one special handling is that, or one special case is withdrawing is done by a queuing system. The queuing system is then is then responsible for withdraw those tokens, and if the queue is done, I can simply claim my liquidity again from the queue. So withdrawing needs always rebalances. I cannot directly withdraw the funds because it could be that funds are active in the strategy and I cannot pull it out right now. So I have to firstly rebalance, move the funds back to the queuing system, and then the user is able to claim. So that's why we need the queuing system here. This is already also in the original code from Trader Joe, so we just forked it right now. Yeah, and that's basically the rough overview of the vault, how they work. Yeah, and let me jump back to the repo. As you now have an overview how the vault is roughly working. Here we have the repository of the vault. As you can see, we have here it's a basic Forge repo. Here you can see the vault factory with different functions. The function which is mainly interesting is the create maker vault or create market maker oracle vault function, which is callable by anybody. We have a whitelist mechanism, so we don't want to, we only allow specific pairs as a layer of security, and also we want to make sure that for those pairs Oracle exists, or the spot price is stable. We have also additional top price checking, but we want to make sure that we wanna don't want to pairs where you can easily manipulate prices or something, because the Oracle reward vault or the Oracle vault is based on oracles, and we just want to have this whitelist as security measure. And as you can see here, we create the strategy, we create the vault, we link it together, then we charge the fee, and we set the pending ARM fee which the operators get, and then the operator is set here by the message sender, and that's it. So the base vault here is holds the core logic, like deposit, withdraw, handling the withdraw queue, and stuff. We had to modify some parts because we have now the reward handling, which I will come to later. Yeah, we have here some let's say abstract methods which can be then implemented in the yeah in the extension. We have the Oracle Vault, which is doing based on oracles doing the deposits. So here we have a in the deposit function, the price is calculated, and based on the price a share is minted, as you can see. This is the amount of shares a user will get, and with this mechanism the user is able to freely deposit funds into the vault, which is, well, I think pretty cool. And based on that logic, we have the Oracle Reward Vault, which is handling the reward stuff. So basically similar like a normal staking pool or MasterChef or other reward farming system. We had some special case here because we don't emitting rewards like a time in a timely manner or something. We don't have an emission rate per second or something because we don't know when the strategy is collecting all the rewards from the pair. So what we do is we have the pair is emitting the rewards. The strategy collects all the rewards from the pair because he is owner of a portion of the pair, and then transfer it to the vault. And then we simply say, is the last reward balance different to the current balance? And then we increase the accrued value, like the accrued token per share, accrued reward per share. And then we can increase the share value and increase the rewards in the system, and users can claim it. Yeah. So this is here the special case. And here we can claim it. Exactly. So, and one last part is the strategy. The strategy is responsible for putting the liquidity into the pair and pull it back. And we have the rebalance function, which is responsible for withdraw first the liquidity from the pair, if any, transfer and execute the queued amounts. So basically, some users withdraw, then they are in the queue. We have to work through the queue and let them out. And we harvest the rewards from the pair and transfer to the vault. Then we deposit back the liquidity based on the range and the liquidity configuration we have here, and then we're done. Yeah, that's basically it. We have also some special handling like a withdraw all. The withdraw all is called in a special case emergency withdraw. Then we withdraw all from the vault, from the strategy, put it into the vault, and users can directly withdraw them from the vault. In case of emergency, we don't need the queuing system anymore, so users can directly withdraw their funds. And we have another special handling, which is emergency withdrawal range. We have a certain bin range at the moment, 51 bins. We also experimented with wider ranges, and we also have chains where we can spread the liquidity over, let's say, 200 pins. But there's some certain cases we are afraid of that we hit the block gas limit. And in that case, we add this function to emergency portions of the liquidity from the strategy or portions from the pair. So we don't get stuck. So in the case we hit the block gas limit, so the whole world would get stuck and we don't get the funds out. So in this case, we want to make sure that we are always able to get the funds out. You can see the modifier only default operator. Let me quickly come back to this because we have different rules. We have the Vault Factory owner, the admin. We have the default operator. The default operator is a trusted rule. The default operator is not the operator or is likely different to the operator, because the default operator is a trusted role. The default operator is in most cases a multi-sig wallet managed by our protocol or some other dev wallet managed by the protocol. And this default operator is always able to rebalance and do stuff in case the normal operator can't do it. For the maker walls, the operator is untrusted because anybody can do it. And we have to be able also rebalance and do stuff in case the operator is not willing to do, or the operator is doing some shit or something like this. So we have basically two operators: the default operator, trusted, and the operator, untrusted. Yeah, and that's a special case because we also have permission-based functions which are all only callable by the default operator. Yeah, and that's it. That's, I think, all the components. We have the test folder. We can see all the tests. I also created a POC test for you if you want to test findings or stuff. Here's the basic POC test, which is creating the factory for you, and you can create a market maker world with it and do stuff with it. One notion is the test is a fork test. So you're operating based on real data. So on the Sonic mainnet, I pre-selected some tokens and also pre-selected the pair for you. You are free to change. You are free to select any any pair you want to fork based on the on the mainnet. Yeah, so it's because we have a lot of moving parts in the system. We have the pair, we have the liquidity book rewarder system, which is not scope of the audit, the liquidity book system, which is not based on the audit. And to simplify things, I think a fork test makes sense. Yeah, and I think that's it, and happy finding.